Okay, so during the last exercises we have been working on improving our array container, and now we will just continue with that. So we already have a find function which is quite simple but does its job. So the next thing we will want to have is some mid, or something that works like a substring, so something that allows us to extract a portion of the array and create a new array with a copy of the objects. Okay. What we also might want to add will be a index of, which works the same way as find does, but with the small change that it just returns the index and not the actual iterator. So the iterators are convenient, but not always. Hence, we would like also to be able to just work with indices, and we'll make our a mid function also just work with indices. Since this is extremely trivial, we will just do it quickly because it's really fast. Index of this can stay, and here we just return I, and else we return -1, indicating that we have not found something. So this is so quick that we really don't need to make this into an assignment. Let's see. Let's make it look nice, but it doesn't change the function. So now to our mid function. It will return an object of type CArray. It takes a Caesar_t start und Caesar_t len, which by default is -1. So the start is the start offset from where we want to take it, and length is how many elements we want to take. And we have here, the way it is made, the liberty of just taking however many elements are left by just keeping the -1. So the assignment here is to well, implement this function, and the simplest way to do it is first to calculate a real value for u length, which can easily be done by just checking size minus u start, and then of course copying the elements over into the new array. How to create a new array, I think we have already seen somewhere here. Where is our array? Use arrays. We used arrays already in split 2, for example. So here, no, not split 2, just split in this one. So here we just created an array and then we append it. So this would be the easiest approach. Of course, one might want to optimize this by adding another function which pre-allocates a certain count of elements, but since here we want to keep things simple, we will just go with appending them. So who would like to implement this function today?
Can do it, I guess.
Okay.
Yeah, I think that's it.
Well, you need to calculate the right value for u length. Leaving it at -1 is not great.
Wait, what do I have to do?
The argument u length, if it's -1, then it needs to be replaced with the right value. The second argument of mid, which specify how many elements we want to take. If it's -1, then we want to take however many elements are left. This means we need to replace the -1 with the right amount of elements which are left in the array.
Oh, okay. So I guess just this then?
Um, this
Or
will work. It
-1.
is serviceable. I don't think we need -1.
Okay.
But there is a edge case. For example, if someone would specify more elements in u length than what the array contains, then it would also run into an issue. So the simplest test is just to check if u length is greater than size minus start, and if it is, then set it to size minus start. Then or greater, or yeah, because if it is greater, so -1 is always greater, because -1, since it's an unsigned value, evaluates to max value. And then if we would add some invalid value, it would automatically gracefully compact this to a range that we can work with. And now, of course, we need also a test case in our main function.
Do we have an array already somewhere?
We have some arrays created with split on string.
Mm-hmm. Crumbs.
For example, yes.
Mm-hmm. There's only 2 values, is there?
No, Crum should have like 1, 2, 3, 4, 5, 6, or 7. Like each section of the path separated with the backslash is one entry.
2, 2. Ah, okay. Okay, let's do. Just do it like this.
You don't need to specify -1 since that's already a default argument.
Oh yeah, sure. Can I just print this then?
You need to make a loop and print each entry individually. There is no shift operator defined on cout, which would take our array type.
Like this.
Yeah.
Okay. Yeah, I guess that's it.
Okay, let's run it. Yeah, you need to remove the breakpoint because it breaks too early. Okay, now we can see in the window. Probably it starts at user, it ignores C users, so it does what it's supposed to, and it accepts the last. Yeah, that works.
Okay.
Okay, so that was quick and fast. So maybe you would like also to improve the functions such that it pre-allocates the count of elements required instead of relying on append growing the array each time. I think we have when you scroll up to the main structure where we store our data. Up. Yeah, it has this capacity variable. So we are already prepared to do this in an efficient way. So, for example, what you could do is you would add a function called resize, or you could also add this to the constructor as an argument, where you can specify the initial size of the array. This would be simpler because resize, in principle, could also make things smaller, which would well complicate things since we need to remove elements. But the fastest way is to add either an argument to the CArray constructor, just called reserve, which by default is 0, and when it is not 0, it would then just call the expand function with the size specified, with the count specified in array, and then you just need to, when creating the array in the mid function, provide this value to the constructor.
Okay. So I just go here,
Not the other one, the one that does not take any arguments.
this one,
Hmm?
and then I do what exactly?
You just add an argument of type size t. Let's
Mm.
call it count, which by default is 0. And then inside the body, if count is not 0, then you call expand with count as an argument.
If count is not 0, I do what?
You call expand, we already have the expand function, capital E, and pass count as the argument. And semicolon. And then in the mid function, you just need to move down the initialization of the array, the construction, from line 153 down to below len, and then you pass len as an argument. That's too far below. You need it in 158.
Oh, here.
Yeah, and just pass ulen as an argument to it. And then, of course, last thing, instead of result append, although this should actually work. So result append will work in this case because it tries to call expand, but if I can have the mouse, I think expand. Yeah, no, it checks here. So if it is if it's already to size, then it doesn't do anything, and it will be to size. So we will just run it a few times into where is append? Append here. We will call this, but the expand will not do anything, and thus no memory will be moved around, and we will just initialize with new values. That will be for large arrays a significant performance improvement. And okay, great. That was it. So
But we didn't resize the array now, did we?
we created it with a already defined initial size.
Ah, okay. But it's not exactly resizing, right? Because resizing does it when it's already initialized.
Yes. So resizing
Okay.
would be able to add defaultly constructed elements to the array or remove elements from the array if we resize it to something that is smaller.
Okay.
Good. So this is it. So what next we would want to so this was homework and begin. We have the thingy. The next thing we would of course like is some sort like insert and remove capability. So let's quickly define the thingy. So we can of course usually those insert and removes are defined such that they modify the current element, it's the current array, so they are not like that they don't make copies, so they don't return anything. We could make them return an error if something happens, but we don't really expect errors, so insert. And the insert is in principle like the append function, just that it inserts somewhere in the middle, and thus it means it needs to move the whole remaining elements by one field, or if we insert more than one element, of course, then by multiple fields. Insert is can be implemented in two ways, either as insert one or as insert many, and the insert menu version is only slightly more complicated, but it's much more efficient since we only move the elements, the existing elements in the array only once, just by more places. But by how many places we move has no effect on the on how computation intensive that is. It's just a different offset. So we will go and implement such an approach. So here, instead of the array, we'll just have a const reference values. Maybe first we'll add the offset where we want to insert it. U offset. And we have our array. Yeah. And the other version, of course, is the insert one, which just takes one value. And they are quite similar. One could, of course, try to save on coding by just making insert one, always making an array of one, and then calling insert on that. But I think this would be not very efficient. So the task here is to implement both functions, but mostly it really is like you implement the lower one and then you just copy the code to the upper one and cut it down a little bit. So it is not very complicated. Any volunteers for this function?
Okay, so I can disconnect, I guess.
Yeah.
Right.
I didn't hear that correctly. Can you repeat?
I can try it.
Okay.
Let's
The sound is really bad. I only get pieces of words. If you have internet issues, maybe you just want to write in the chat. That might be that works with any amount of bandwidth.
Is it better now?
Your sound is very choppy. If you have issues with your internet, you can also write in the chat what you want to say.
That's nice.
Okay, I see you connected.
Okay, so first probably the size. So let's play. No, it's already, so the size is already get size, right?
You can get the size of the current array with get size, yes.
This. So, okay, then I guess we have to use the expand function, right, to make it.
Yeah, that would be the first step, expanding so that we have room for one more element.
So it's then 2 plus 1. So observe the position, right?
I really only hear every second word. Can you do something with your sound to improve that? Or instead, you can write text in the chat. If the sound cannot be corrected, that would be also a good option.
Okay. Now it's more.
Is it better like this?
Yes, much better.
Okay. Okay. Well, then let's continue. Expand. Okay, so mm, T. So try now to implement that we shift everything to the like backwards if we
Yes.
insert something in front of it.
Mm-hmm.
So that's you. What's that? And backwards is Mhm. Okay. Inserted. Um, there already a function in the structure.
So to do what?
Now I wanted to like insert it. So now I shift everything to now insert something at that position.
Yeah.
Like element. Uh, is
So
there
there is one issue with the add function. The function is not aware that we have that the size got bigger, so to say,
ah
because there was nothing inserted. So it would be so one thing you could do simply is to just look into the add function and copy its functionality except the bounce check.
mm,
No, wait, let me think, because this is kind of a bit complicated the way we did this initially. Um, I think the most elegant solution is that for the add, that instead of expand, you would just use an append of an empty element to grow the array, and then you shift everything, and then you have already the indices as they should be. So instead of expand t plus 1, you just write append, and as argument you use just the type t with open and close brackets. That creates you a new empty element, a capital T, and yeah, open close.
oh.
Yeah. So this adds one element, then the add will work correctly, and then you just, to insert the new element, you can just write add at u offset is equals value. That should already do it. So now we need a test case in our main function to see if this works correctly.
Mhm. Mm, Then insert the oh, no.
No, you can for example use the existing crumbs array to add something to it. So you call insert on the crumbs array, and this will change the crumbs array by adding whatever you have inserted. And you don't do that you don't print this out, so our insert doesn't have a return value.
Insert.
So just in an empty line can call insert on the crumbs array. Not the other way around. Crumbs.insert.
Oh, sorry. That already something.
We just need to find a place to insert. So for example,
3 or something.
3 is okay. And some new string. You could, for example, insert comma quotation marks test quotation mark as an argument. Oh, desk, yeah. But closing
Inside the
brackets.
brackets.
Yeah.
Like
No,
this
no.
one.
The brackets you are closing after the number 3 should be closed after the quotation
Yeah.
mark, and instead you need a comma. And now you can just copy a line which you can just copy a line which prints the whole thing, and then start it to see what it will be doing.
Yeah. Like this one. And then just
No, we need something with a loop.
There you need the loop.
The one above.
Well, yes, if you remove the mid 2 from it and just have crumbs, then it will do. And you are missing a semicolon in the other line, 124. Yeah.
Yep.
Okay, let's run it. Say user desk source. Yeah, that seemed to work. Okay.
Okay.
And now we need the other one, the one that can insert multiple ones. So, yeah.
Right. Because I can copy most of it, right?
Yeah, in principle, yes, but you will need to change. Well, the way you did it, you need to change a few things. Because, for example, append only appends one element, and you don't want to call like append multiple times because it would make a copy each time. So you could have, that would be reasonably efficient. You could call expand with the right amount of elements, and then call append in a loop, because append, if it sees that there is enough room in the array, it only runs the constructor which we need for this add operator to work. So yeah, you can copy it and then just add a few more things to it that will yield a reasonably efficient solution.
So that's like so I have to define a new number, or what is the argument of expand? So
It will be the new count of elements, so it will be t plus the length of the values array. So basically just values dot get size.
Yeah.
Mm-hmm.
Yeah.
Yeah,
Okay.
you need the brackets for the function call. Mm-hmm. And then you would need a loop where you call append the amount of times as many there are entries in your
New.
values array.
Mm-hmm.
So don't change this shift array, just undo the change in line 194. Just make a new loop instead,
Okay.
because the loop is different. The loop you need will run from 0 to values.size.
Okay, so uh,
So the copy loop you can keep as it was in the previous function. Just add a new loop before it.
so
And you change something in line 192 that also needs to be undone. I think I equals uStart. You remove the uStart, just re-edit.
so
Mm-hmm.
mm. So you mean it like this? So insert a new
No,
for
the loop should be before this loop.
Okay, so now I need from 0 to get from value from the size of value.
Yes.
Right. Okay. So you start is 0.
Mm-hmm. You start with 0.
Yeah.
No, you make a new variable, size underscore t, I is equal 0. You already used the t for the size. You can use I again since it's in a different loop. Mm-hmm.
Is equals 0. And then it's so t and so u offset is equal. No.
We just want to add as many elements as the values array contains, so that we have empty elements to which we can then shift the existing elements.
So it's like for I, so until I is equal to the value array.
Well, I is less than values dot get size.
Uh,
Not equals. Equals would be one too many.
and then um,
And you need I plus plus. The loop should be independent. You don't need to move the one to each other to not be correct. Just
So I thought this loop will be inside the other.
no.
Okay.
In the first loop, you only call append t like in line 175. The loop just makes you call this append multiple times, and since we already have allocated the memory with expand, it's a cheap call, so it will not cause any unnecessary.
Okay, so it depends until we have the size of the
Yes.
new array. Okay, yeah, now I understand. Okay. So then that's it, isn't it?
Well, you are missing the append, right? The first loop is missing body. It's looping and not doing anything.
Yeah. Append. So now I append each time one item until I have the right size. Yeah.
Yes.
Okay.
Then you do the shift, but the shift will need to be changed because you are not shifting by one, you are shifting by well, by however many elements are in size of values. So maybe it would be a good start to introduce a new variable which will represent the size of values punct get size, so that we don't need to call this function so often. Like in line 188, the same thing, just different variable for the other size. A dot, not a double dot. And once this is fixed, you can replace the other calls with the variable. And in expand as well. Okay. So now you need to think about how to modify the loop to shift by more than one element.
Okay, so here I shifted like one item backwards each time, so that should probably be changed. So then that's Q. Oh,
That will not be the only. That will not be the only change. So when you start this loop, then I is pointing, well, to start.
start. Yeah.
And you have not defined start yet, so you will need to define this correctly.
So you start. I thought you start at 0, isn't it?
No, when you so in the
At
previous
the
loop,
beginning.
when you started, your start was the count of the size of the whole thing.
Okay. So it's
Wait, let's see.
get size. The get size was the initial length, and now we have T plus Q. Or do we still use U offset?
Uh,
Or like,
so
You get
This will need a bit more changes to the loop in either way, because the way you want to do it is you want the start to be like the last offset in the new array. So the last offset in the new array would be t plus q, but minus 1. That's the last valid offset in the array.
so here.
No, this, wait.
Okay.
This is to be changed later. First, you need to define
Okay.
start, from where you start your operation. So the last index you want to set, and that would be
T plus Q.
and minus 1. So t plus q minus 1. Wait, is that correct? Yeah, that should be correct. And you need the equal sign, and you need the type before the variable name.
So no. That's okay. And that's yeah.
T plus q minus 1. That looks reasonable. Okay, then we start. Then we
Yeah.
copy, and then what you need. And you are not longer going to offset. You can define. Wait, no, you do. This is correct.
So now
But you will need and then not minus 1 but minus q.
so I start here and then I go one step down.
Might be correct.
Or is this still wrong?
It is wrong as far as we changed the meaning. What did we wait? No, that should be fine. That should be already fine, I think. Yeah, that should be fine. So what we are missing now is another loop which will now insert the new element. So you have this add uOffset value, but this only inserts one element. You need to have a loop instead which inserts all the elements in values, one after the other.
Okay. So I create a new loop.
Yes, correct.
And so then from T okay, and now it's
Well, it probably will be from 0 to q.
added to value. So what exactly am I have to do it now? So
You
now
will call add is equals value multiple times for the right offsets. Not from values. So for example, you could go with add uOffset plus I is equals values at I. I, not 1.
Okay, all right. Equals to values. Values plus 1 or Can you repeat it?
Values dot add from I.
Okay. Mhm.
No.
But that remains the same, or no, that has to be removed. What?
The last line needs to be removed, yes.
Yeah. Okay. Okay. What is missing?
Test case to see if it's working.
Okay. So now can I just copy it and change the argument?
Well, you need to create a new array with more than one entry, and then you can just change the argument of insert to, instead of taking just the string, to instead of take the um, new array of multiple entries.
Okay. So then it's the array. Mm, mm, mm. So it just create a bunch of words.
Yeah, well, you create the array just by open close brackets, and then you call append on the new array with each word you want to append.
Okay. Mm. So if I want um, add but still in this already existing array.
Yeah,
Oh,
well, you need a semicolon. Oops, in the semicolon at the end, and then you can call and
mhm.
drop the round brackets. They are not necessary in this case.
Okay.
And then you just write a new array dot append, and you append a word, then you repeat that for another word, and however many words you want.
Mhm.
Yeah.
Let's continue.
Comma, not semicolon inside. And you can only append one at a time. You need to call
Ah,
append multiple times.
okay, then I just uh, copy it.
Yeah. Um, it's not an array of char, it's an array of string, it's C string X.
Ah, yes. Sorry. Okay. And now I insert the new array.
C string x is missing template argument. The C string x is from char. C string
So,
x, and it's like it's defined in line, for example, 110. You need to add the char argument to the C string x template name.
mhm.
Yes.
And now do I just do the same as before, but
Instead of desk, you add a new array.
right, yeah, okay. Um, ah, do I still need the loop?
Yes, yes, you want to print it, of
Okay.
course.
For- Mm, so- Okay, can I run it?
Yes.
Not save file. Yeah, okay.
Okay, seems to be working. It's
Yep.
not missing anything. The index seems right. Yeah, perfect. Good. So that is that. You can disconnect.
Yep.
So the next thing which we will want to have will be the option to remove something, which is somewhat similar to mid. From which arguments it takes. It takes just the start offset and count. But the remove thing is a bit tricky because we here have not really taken a look on how to actually get rid of an object that we have. So when we look here, we have, where is it? Here we have a rather complicated mechanism that allows us to save on some memory and allocations for smaller objects. But this in turn means that we will need some way to deallocate them and remove them correctly. And let's see, we have here our release, which makes free, which is not actually feature complete, so that will need to be fixed first. So the thing that happens here is that but the remove doesn't return anything. So the thing that happens here is that we only free the memory, but what we actually needed to do, which we forgot, is we need to call the distractor, because here like we call the constructor, so we would create an instance of type string x, for example, as we used, but without actually calling the distractor we would never release the string, and then we would run into a memory leak. This issue we actually have missed the last time we well, at the time we created this append function. So first let's correct that, and we can do this in we can add, for example, a function which will just deallocate something at a given offset. So let's call it release at cz index index okay. before we free it, we have a loop for in size 10 e is equals null, e is less than m size. Release at I. Okay, that we already had here. So this takes care of this release operation, but we need still to implement it. We can copy a little bit of our code from here, and we'll have that will also not be ideal. We are taking it at this offset. Yes, okay, let's copy this code. Zack. Let's release it. Okay, so if we have the special case, then we just need to call on our entry the not size t, we go with the actual offset index punct tilde t, and in this case we work differently. We just use the destructor, so delete at okay, so this function can now be used to make an element kind of empty, so as if it would never have been initialized in the first place. In this case we could add a small improvement to set this pointer to null, which in case the function is used improperly would help to find this error faster, but it's kind of not a necessary operation, since we expect that this operation here will always later deallocate it. So we might not do it, but since we want to make it rather safe, let's just do it. And in this case, of course, since we are using the memory we have in place, we could zero it, of course, but this is not strictly speaking necessary. Let's just see if we forgot something. Yes, we did forgot one detail. So our type here is always pointer, but here, of course, since we are kind of abusing the pointer as well as the non-pointer, we need to do this before we can call the destructor. So or we can just not do the this is not correct. Good, that should be right. So we have our pointer, we take the pointer on our pointer, we convert it to a to the type asterisk at this position, and then on this we can use the arrow operator to access the destructor. That should work. So when removing elements, what one will need to do is to have a loop similar to this shift, well, similar to one of those, to this append loop or to the shift loop, but working at the offset from where we're removing until we are removing. All those elements will need to be released with this, and then they will need to be assigned new values from the element that is removed. So let's write an example for that. Example is equals let's grab some array we already have. Let's go with this. array punct remove let's say so 0 1 2 let's say 3 comma 2, and now it should result in array being equal, so 0 1 2 3, and we want to remove 2 elements, so it should result in this. And as said, you would need a couple of loops, so that one loop first clears the space with release, so that the elements get deallocated, and then you would copy elements there, although you cannot use add, since add assumes the memory in this place to be valid and uses the assignment operator of the type that is used, and since we have deallocated this memory, this will not be valid. So this of course complicates things. One could of course kind of create like a remove one function. Maybe I should do that as a demonstration myself. So we have our remove, but we call it just remove one. It just takes offset, not start, because this one is like remove many. However many we have specified, and remove one will just removes one entry. So what we basically do is we just call release at well, offset. We could maybe of course first check if offset is greater equals get size then return, because it doesn't exist apparently. So now we have freed it, so at this point in the memory is not it's not allocated, it's not initialized. So to help with this, we can create a new function create add, and we will need to specify well, we will not really need the create here, this would be for later. I'm thinking how to make this not too complicated of an assignment. So first of course we release the one element we wanted to release, and then we need to move everything by one, but move it in a correct way. So let's make a move function, or we could also call it a swap function. That would be perhaps even more elegant with regard to what we want to do. Although if we just swap, then it would still assume that we have valid entries. That actually that complicates things as well. Because when we make a move function, and we would assume that we are moving to a place which is not yet valid. Well, before we make some more helper functions, let's just implement the remove one, so that we see what it actually, how it actually has to operate, and then we can think how we can generalize this. So we start with a loop, then that will then move things into the into the gap. So once we created kind of an in-between gap, it would be like kind of something like this, but not quite really, because in reality it's like rather null. So once we have created, in this case, one just with one missing one here, we will start at size t e is equals offset plus 1, and then we want to move everything. It is of course, unless we remove the 0th element. Okay, then let's go with this. We start at offset. Then we have e must be less than get size minus offset. We can make a variable. so that we don't query this function too often. So we go ES size plus offset and then I plus plus. Okay, so if we would be in the case where we have the first element, remove it and then we remove one which is one higher, and E must be less than size minus offset, but then we can kind of make size no, then we just take I as is. So we would want to assign at I something from I plus 1. And the thing is, I said that this assignment operator will not behave correctly, so we could copy it and then make it work as it should. So we are here.
Sorry,
Yes.
but why is it so size like get size minus U offset? So I is smaller than size minus U offset and not size minus 1?
Oh yeah, right. That should be because we always shift by one element.
Yeah,
Minus
okay.
1 is correct. Minus 1. Right, and then we will have different behaviors depending on in which case we are. So in the lower case, this is kind of a simple one because we only shift the indices, so we can just go with at E is equals I plus 1. So this is kind of the trivial case. The more complicated case will be this one because here we will need to copy something from the constructor which we had invoked here. This one, suck. So we basically create a new element from the old element at the old offset, which is located here. And for this, yeah, so from I plus 1. And then we need to get rid of the element, so deallocate this memory which we have kind of copied, because we really create a copy, so we can use for this our release operation. But since this would be a bit redundant, we go with this I plus 1. So we kind of initialize a new element at the position. This is so wrong. This needs to be I. We initialize a new element with new at the position I, and we tell it to use as an initialization value and the value which is stored at I plus 1, and then we create a copy, so we have two elements, and then we need to deallocate the other element which we have created, so that this is empty. And once we are done with this, we can set m size minus minus. So we have reduced this thing by one element in size, and this should work. Let's try it out. Okay, so we have some array. Let's modify this maybe slightly so that we let's do it like this, and this is so we can copy this. Just changes how this thing looks. It makes it a bit nicer. So let's say we want to remove number 2. Okay, let's run. This should have been probably somewhere here-ish. Okay, so let's run it. We forgot something. Yeah, semicolon here. Oops. Okay, so didn't work. Why did this didn't work? So if size if offset is bigger than size, it should not be release at offset. Crumbs, that should be right. Let's see, so we enter our, oh, I called the wrong function. It is remove one. Zack. Yeah, and as you see here, this seems to be working correctly. We removed user. It was at offset 2. Yeah, 0, 1, 2. So this works. We can also change it to, for example, remove at offset 3. And then of course we need to change the edge cases test the edge cases if we try 0, and if we try 0, 1, 2, 3, 4, 5, 6, 7, 8, if we try 9. Okay, seems to be working, but just to be sure, let's step through 9 to see that it does what we want. So we have this, it releases the element at 9th position, and it doesn't do anything because it does not need to do anything, and that works fine. So this is correct. Okay, let's switch this back to 3. Test case. Yeah. So the homework assignment from this lecture will be to implement this function. 0, 4, 12 to 0 to 5. We should really call it remove many, because otherwise one might get confused as I did and call the wrong function, and and that's then not great. Yeah. Yeah. Okay. Good. And since we have a few minutes left, we could take a look how with this methodology improve the insert function to be a bit more elegant. Let's call this just insert menu, and let's see how I would implement that from scratch, so that you have like a reference implementation how this would be the most elegant way. So we're missing a test case as well. So first of all, we should check if offset is bigger, or actually if it's only if it's bigger. No, if it's equals, then it's also wrong. So if it's bigger or equal size, then we of course cannot insert it, because we would there wouldn't be enough. We would have like a gap in the array. So in this case, we would return an error. Alternatively, we could of course make this so alternatively empty elements. But for now we don't want that, we just return and don't do anything. Okay, we can of course expand this, so this will of course be also needed. Then the size of the new array will also need, so we can then create a second st2 second size, so size plus size 2, so we expanded that we have enough room. And the wasteful part is this append, because we kind of create an empty element just for the purpose of overwriting it. So we don't need to do that if we instead use our more advanced way of shifting things. we also start at start and we work from the back, so this doesn't change, but this here does. So let's see one for one. So this part again is quite simple. We can use this as it was done here, just with minus I. And this portion, actually we can keep this similarly simple. We initialize from this and then we free that memory. So this works perfectly. We are then just leaving unused uninitialized memory. As a safety precaution, we should probably here just null the other one, so that we are on the safe side. And here I will do the same. +1, so that we don't have like any data left that might look like it might be valid for something. Here we could also do the nulling, but since we are not working with pointers, we will just ignore that. Okay, so here we did this, so then we can just append like here, although again we will not be using add because the memory there, it has been it's just some random garbage or null in this place, so we'll need to change this to use the actually we'll need this whole mechanism here. Where did we were in setting? At I. No, that was I'll just copy this so that we don't forget the right offsets. Otherwise we can just grab the constructor from append and make it use different positions. It is more elegant. This one. Yeah, this is more elegant. Let's ignore the other one. Just instead of size of t, we are going with offset plus I. And the value is just not is of course not just value, but it's from values at t. At e. Oops, we want to use at, not square bracket operator. Although it would do the same thing. Values at e, right? At I to offset plus I. That should be correct. And since we are not using append, but those operations here, we will need to manually modify the size variable, but just plus equals s2, because expand, as you might remember, it only changes the capacity and then reallocs the whole thing. And if realloc size, wait, capacity, oh, we forgot to update the capacity, did we? Yes, we did. That we should fix, because this realloc, it will reallocate the thing, but then on m capacity we need to assign the new capacity to it, otherwise this will not do anything, and we will always try to expand it, yeah, which is not great. Okay, so we fixed this bug as well. Okay, so expand now should be efficient. This is done here, this is done here. We add the new size. Okay, so let's just test if our so first we run it as it was. We have a few mistakes. We didn't copy the start value. Although I think we use start only once, yeah, so we can it was the two sizes -1. So just sz plus s2 -1. I think q is also not valid, that is s2. S2 have more queues. S2. Okay, that should be all of the queues. Right, so the original function gave us a string like this, so now we switch it to our function. Insert many, run. Crash. Okay, we screwed up some things somewhere. Or insert many is not working as it should. It broke something, so let's put the breakpoint here and see if it broke the first one or first two. The second one is already broken. That is not great. So we have some issues with offsets somewhere. Let's see what is not working as it should. So we enter our function. We get the size, which is 3, so we have 7, that makes it 10. Let's enter expand. That will be a problem. It will be a problem because when we reallocate and we don't have just pointer types but the other type, then since realloc might change the memory block in which we reside, that might result in the problem. Although the way we have implemented it currently, it's not self-referencing, so that should fail. It should fail gracefully. We should. That will not be the underlying issue, I think. Wait, let's run it again. Let's go to our many function. Let's assume expand works correctly. Okay, so we start here. We want offset 9, and we want offset 9 minus 3 is 6. That looks correct. Then we deallocate whatever was saved in 6. Here we hit 9, okay. Well, that should be correct. And then here we have our insert. So we start at offset 0. Offset is 3 plus 0. That should be at offset 3. It also looks like it is correct. Okay, but we still bug out at the second offset, so that would suggest that something is not quite right with our grow thingy. So let's quickly change this from size t e is equal to 0, e is less than grams punct get size e plus plus, and here we want grams punct at I mean, this will also crash, but I just want to see that it really crashes at offset 2. Call stack, zack, grams, and it well, at offset 1. Yeah, but this is an offset we have not technically touched. So let's see what happens here that we don't want to happen. So the first call should be fine, and it was, and the second call will somehow not work. So we have this, we go into this case. Then we go into this string here, and this Okay, let's step through this quickly. Okay, so this has no m, and it doesn't have, it has int if it does not have any m. This means we must have access to an invalid offset, because we somehow have cleared this thingy. That was not what we wanted. So let's see. Oh, we have only 3 more minutes, so I should hurry up with fixing that. Okay, so let's see. I mean, for starters, we can just this is the case where it fails. Let's see. So we are going for the offsets 6, 5, 4, 3, 2. Okay, it is not correct. We are shifting something the wrong way. E. The other functions, but the other functions seem to work, and it went to sz -1. Alright, then this should be also sz -1, sz -1, because if the other one worked, then this one should also work. That might have been just an issue while copying. Let's see. Okay, it still failed. At which offset? Okay, it failed at 6. That is already better. So we have users, file, download, saved, but then it failed. So at this point, it should have had the desk, I guess. Okay, so it's improved, but it's not quite right yet. Let's see. And here we start at 0, offset plus I, offset plus I. Let's put a breakpoint here and see where we're actually adding. Right. We might have shifted it one too much, because this portion also worked correctly, just the one entry after it was wrong. The one entry. Oops. Just so we are copying this offset to this offset. Oops. And okay, let's see. So we copied 6 to 9, 5 to 8, and 4 to 7. 0, 1, 2, 3, 4, 5. 6 is missing. Wait, remove something. So this is the original string. 1, 0, 1, 2, 3, 4, 5, 6. And we add the 3. That should be 9, 0, 1, 2, 3, 4, 5, 6. Yeah, this is not correct. This should go to 6, and this should go to 7. So 9. So 0, 1, 2, 3, 4, 5, 6 goes to 9. That's correct. Yeah, 5 goes. 6 goes to 9. 5 goes to 8. 5 goes to 8. And 4 goes to 7. Yeah. 5. So we have the original string goes until user 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 6. We did this one too little. We need should go one more. This should go just as set apparently. Wait. Oops, that went the wrong way. So we started I at this position. Do you want to wait. I want to go as many as are left. So this will be offset sz minus offset sz minus offset. Why did the other one work then? Insert many. That will need to be checked. Okay. Wait, not quite. That was too much. Where's my bug? We only want to go to. We start with the last element. No, we start with sz. Yeah, so we start here with the position where the last element will be or the next element will be after the thing that we have inserted, and then we're taking the elements. Trying to be right, and then just the count of the elements is to be determined, but we don't do the count, we do the offset. So we actually here need to find the offset of the last element. That will be, but it should be a set minus 1. I'm just experimentally testing something out, and now it works. And now it copied all the 4. Let's quickly invoke the other function to see if the other function actually worked as expected. Just insert many. Maybe the other function is just silently. Wait, we don't want to do it with the same array. Let's do we add a copy constructor to our array? We should have a copy constructor, so let's make a new array. Auto test1 is equals crumbs. Oh, I see we are already out of time. Sorry about that. 2 run. Okay, we have some more bugs we need to fix. The copying here apparently did not work quite right. So let's. I will fix the copying constructor later after the exercise. I just want to see if we get from both functions the same result. Okay, so this is the result that the function get before gave us, and this will be the result. The newly and improved function gave us. Okay. For whatever reason, it seems to be actually working, even though there seems to be some inconsistency with the offsets. Oh, I know why. Because we copied, we cached size. We cached size before we expanded the thing that has shifted the offsets. That's why here we need to change the comparison. Okay, but this is working. So we are done for the exercise. We'll see each other for the lecture. I will upload everything to Moodle. I will nevertheless fix why the copying is not working correctly. That should not be. Yeah. So I'll stop the recording.